Last time we completed the phasor, impedance and admittance functions. We solved two problems there. Today also we'll take some problems and we'll start the session. Last time we have calculated this, I think, Zn. Let me take pen first. Yeah, last time we have done this. Come to the third one. And in the third one they are saying find Ix over here in the circuit of the figure. See, this is the circuit given and this is the completely AC circuit. By looking you can judge it because we are having here AC source, here AC elements. Remember, inductor and capacitor, they are fully AC elements. Why? Because they are significant in AC circuits only. In the DC circuit they are useless. For the DC circuit the inductor behave like a short circuit and capacitor behaves like an open circuit. Okay, so come to the point. He is asking for the find out the Ix. Where is the Ix? Ix is over here. Okay, so while solving this circuit, first convert this circuit in the form of impedance. Means here if you observe this inductor, they are given the value of inductance, but I need the value of reactance. Okay, so you know the inductive reactance is nothing but j omega L. Similarly, for the capacitor, the capacitive reactance Xc is nothing but 1 by j omega C. So first calculate these two terms because it will be useful, and this entire thing will convert your circuit in the form of resistance or impedance functions. So you can easily calculate all currents and voltage in the branches, right? So first I'll convert 1 Henry j omega L. J, what is the omega? This is the source frequency over here, and single source frequency is given in the circuit. Suppose you are in multiple frequencies, means here it's connected 20 cos 40 and here they are connecting suppose 10 sin 40. Two different frequencies. 40 instead of 40 here it's connecting 10 cos 2t. Second frequency. So here in that case we'll apply the superposition theorem. One by one we will consider the sources and we'll find out. But here we are having only single frequency. So in a single time, in one time, I can do it. I can solve it. So j omega, what is omega? 4. L, what is L? 1. So this is nothing but 4j. The value of this 1 Henry become 4j in the form of inductive reactance. Now come to the 0.1 Faraday, 1 by j omega C, 1 by j omega C, 1 j as it is. This is 4 and C is 0.1, it will be 10, so 2.5 and this will be minus J. So this is minus 2.5 J. Correct? What about this 0.5? It will become 2J. This is your circuit now. Now you have to find out the Ix. So convert to this source also. This is nothing but 20 at an angle 0, right? What is the general expression? General expression is Am cos omega t plus phi. Here the phi is 0. So it's 0. Amplitude is 20. So I'm taking directly 20. So this is 20 at angle 0. Now your question become like 20 at an angle 0. Perfectly fine. 10 ohm connected over here, and this is impedance function minus 2.5j. Perfectly fine. Come to this. This is 4j. Okay. Minus 2ix like this, and here this is 2j. This is inductor. Okay. Now he is asking for the Ix. Ix is nothing but this. So you can do it by nodal analysis. It will be easy because if you will take this problem by mesh analysis, you are having 3 meshes. You will be having 3 equations. And if you will do it by node analysis, you will be having 2 nodes. You will be having 2 equations. So it will be easy to solve by nodal analysis. Take it V1 take it V2. Okay. Now I'm going to solve it. Node analysis is V1. V1 minus 20 at an angle 0 divide by 10 ohm plus V1 minus 2.5J over here plus V1 minus V2 divided by 4J equal to 0. Equation 1. Three branches are connected over V1. You should be having 3 terms in the equation. Yes, we have 3 terms in the equation. Perfectly fine. Now, if you want, you can further resolve this. I'm giving this equation. Now, come to the equation 2. Extremely sorry. I'm writing over here V1 minus 20 divided by 10 plus V1 minus 2.5J plus V1 minus V2 divided by 4J. Equation 1. Now we'll take equation 2 over here. So this is V2 minus V1 divided by 4J plus V2 divided by 2J, and here we're having 2x. We're getting 2x, so minus 2x, it's incoming current, equal to 0. Now, if you'll consider Ix, you'll be having 3 variables in 2 equations, V1, V2 and Ix. So you can remove this Ix. This Ix is given over here. Here the Vx. Ix is nothing but V1 divided by 2.5J. Like this. So you can replace this Ix if you want. So replace it. This Ix will replace by this. So it will become plus 2V by 2.5. Okay. 0. Equation 2. When you will solve this equation, you will get V1 and V2 value. So I will solve it for you. When you will simplify these 2 equations, so the new equations you will got will be 1 plus 1.5J V1 plus 2.5J V2 equal to 20. This will be equation 1. And in the second equation, you will get 11V1 plus 15V2 equal to 0. This will be equation. How to solve it? By matrix method, I'll tell you. If you will convert this in the form of matrix, so your equation will be, it will be look like 2.5J. It will be 11. It will be 15. Okay. V1 and V2, 20 and 0. Now, if you will find out the value of V1, it will be del 1 by del. Value of V2 will be del 2 by del. Where what is the del? Del is nothing but determinant of this. Determinant 1 plus 1.5J multiply with 15 minus 11 2.5J. Okay. So it will be 15. This will be 15 plus 15 into 1.5, 22.5 minus, what about this 11 and this? So 22 and 27.5J. Is it okay? So it will be 15 minus 5J. This is nothing but del. Now what is del 1? The question is, del 1 is nothing but to calculate del 1 in this matrix. Instead of this V1, this is the V1 column, this is V2 column. So in this V1 column, you have to put these values 20 and 0, and remaining will be same. In this way, you will calculate del 1. And del 2, if you want to calculate, instead of V2 column, you have to put these values. And here, it will be as it is, like this. Now if you will solve it, so you will get, so if you will solve this, you will get V1 equal to 18.97 at an angle 18.43. V2 will be 13.91 at an angle 198.3 in volts. This will be your answer. So like that you have to solve. So friends, if you will observe this is the AC circuit, okay, fine. But when you will put this frequencies value and you can convert this entire circuit in the form of impedance function, and once you convert it into impedance function, you are free to apply KCL and KVL or any circuit theorem in the circuit. So the rules, whatever we have learned in the first unit, will be applicable for this one also, for the AC circuit also, but you have to remember that please convert the circuit in the form of impedance function. Instead of inductor, you will be replaced with j omega L, and capacitor you will be replaced with 1 upon j omega C. Okay, because this is the impedance equivalent of this. I hope this is clear to you. Now come to the next one, find V1 and V2. This is the homework for you, and I given the values of V1 and V2 also, so you can cross check it. Now come to the next one, find the Thevenin equivalent at the terminal A and B. For this circuit, they're asking Thevenin equivalent, right? So Thevenin equivalent they're asking. So see here, they're already given in the form of impedance function. This circuit is like simple resistive circuit, but instead of resistance here, you are having impedance also. So for the Thevenin, if you remember, for the Thevenin terminal or Thevenin equivalent circuit, you need two things: R Thevenin or R equivalent and VTH, V Thevenin, across point A and B. So here A and B also given. So first calculate the RTH. What is the procedure to calculate R equivalent of the circuit? To calculate R equivalent of the circuit, you have to turn off the all independent energy sources. Here we are having only voltage source. How we will turn off the voltage source? By making it short. So this is short now. So these two branches are connected in series. 6 plus 2j. 6 plus 2j is in parallel with minus 4j. So the equivalent of this is 6 plus 2j minus 4j, 6 plus 2j minus 4j. So this is 6 plus 2j minus 4j divided by 6 minus 2j, multiply 6 minus 4 minus 24j, and this will become plus 8. 6 minus 2j. I hope this is clear to you. Now it will be 8 minus 24j divided by 6 minus 2j. Take 2 common. 4 minus 12j, 3 minus j. Is it okay? This is nothing but the equivalent of this circuit. In this you have to add 10 because they are connected in series combination. So your new equivalent resistance is 4 minus 12j, 3 minus j plus 10, finally 3 minus j, 4 minus 12j plus 30 minus 10j, finally 34, 4 plus 30, 34, and this is minus 22j divided by 3 minus j. Is it okay? This is nothing but your R equivalent. Your R equivalent is nothing but 34 minus 22j divided by 3 minus j. Is it clear to you? Okay, fine. So you calculated RTH here. Now your next task is to calculate VTH. VTH across this point. What you will do? Apply. This is the open circuit, right? This is 0. By nodal analysis I'll do. This is the open circuit, there is a no current. Here the voltage is 0. Here this is VA. Okay. In this equation only one node is there. You can apply nodal analysis easily. You will get VA minus 75 at an angle 20 divided by 6 plus 2j. Okay. This will be VA and tell me minus 4j equal to 0. Okay. So at the end you can take 6 plus 2j and minus 4j So it will be VA minus 75 at an angle 20 multiply with minus 4J plus VA 6 plus 2J. So we'll solve for VA. You will get some value. So when you will calculate this value, it will be 47.42 minus 51.57. This is your VTH. The difference between these two terminals. Here the voltage is 0. So VTH is given over here. And you calculated already the RTH. So this is the way to solve it. Now this is for you homework. Okay. Come to the next topic, and that is the AC power. This is the very crucial and very important as for the GATE exam, because in frequent years we are getting the questions from this only. Come to the power. First I'll tell you the general formula for any power. General formula is nothing but VT, IT and the angle between them. This is nothing but power. I think you know about the power. Power is nothing but the energy transferred in per unit time from one source to another. If this is A, this is B, they are connected by some circuits or conductors. Now we are sending energy from A to B. So energy per unit time is nothing but the P, and the unit of the power is nothing but what? This is brief about the power. But come here in the AC powers. In AC power, the first term is the instantaneous power, PT, denoted by PT. So what is the instantaneous power? If you will see, the instantaneous power PT absorbed by an element is the product of the instantaneous voltage VT across the element and the instantaneous current IT through it. Assume the passive sign convention. See friends, if in the circuit element is given, in that element the current is IT, at an instant the voltage drop across this is given VT. So instantaneous power. At a moment, the power will be given by multiplication of VT and IT. Simply, this is the instantaneous power given by multiplying current and the voltage value at particular time itself. So the instantaneous power in watts is the power at any instant of the time. At any instant of the time, suppose someone will ask at particular time what is the power in the element, you will immediately say multiply the current with voltage. Right? Now, the instantaneous power changes with the time and is therefore difficult to measure, because this is the time dependent parameter. VT, IT, they are changing continuously with time. So it is very difficult to get the value of instantaneous power. So instead of this, we'll use the another parameter, and that is the average power. The average power is more convenient to measure. In fact, the wattmeter, the instrument for measuring power, responds to the average power. See, in the AC, this is waveform of VT, suppose. This is waveform of current, suppose. Right? They are changing continuously with time because they are time dependent waveforms. So the power by multiplying these two terms will also be having similar kind of waveform like this. In the resistance, the power will become like this. Okay. So the power is also changing with the time. So we can't take the individual values at every time. So that's why the concept of average power is coming into the picture. It's like, suppose, see, you are staying outside, suppose you are studying somewhere in Delhi, your father giving you money, and every month for Jan to December, from January, suppose he is giving you 4,000, in Feb he is giving you 5,000, next month suppose 1,000, like this 7,000. At the end, at the December, suppose someone will ask you how much money your father is giving to you, what you will reply? That in January he gave me 4,000, in Feb 5,000, in March 1,000. No, you will give an average value. We will say that 4,000 per month at an average he is giving to me per month. Like this. So this is the significance of the average value. Similarly, here also in the AC circuits, we can't give the instantaneous power because it's changing continuously. So we need to come up with another point, and that is the average power. I'll come to the average power over here. The average power in watts is the average of the instantaneous power over the period. Suppose this is the period. In the one period, if this is the average power, so I'll take the average of this. If this is the instantaneous power, I'll take average of this. And why I'm taking the power graph like this? See, if the Vt is like this, what will be the current across in resistor? Same phase and something. The power across resistor is V into T. V into this is the power Pt. P is nothing but Vt into It. Okay. In this reason, both are positive. If you multiply these two, you'll get the positive term. In this case, this one is negative, this one is negative. When you multiply, you'll be having positive. So this is the power graph for resistance. Like this, like this, like this. Okay. That's why I'm writing the equation like this, or the graph like this. So this is the instantaneous power. So when you will average it, you'll be getting average power. Okay. So the average power mathematically given by P is nothing but, you know, the average value of anything. Average value, suppose we're having some numbers 1, 2, 3, 6, 7. What is the average? So here you will write sum of the numbers divided by total numbers. Total numbers, right? Similarly, if you want to calculate power, so in the numerator, the sum of the numbers, sum means nothing but the total power. Total power was 0 to t in one time period. We are considering 0 to t. Total power you will take. You want to get average power. So first you will take total power. So total power is nothing but, we are integrating the power from 0 to t. Divide by total time. The total time is t. So P average is nothing but 1 by t, 0 to t, pt, dt. I hope this is clear to you. This is the average power. Now friends, if you are taking Vt is Vm cos omega t plus theta v, this is the phase angle. Take current It is Im cos omega t plus theta I. Theta I is corresponding to the current I. When you will find out the P, means you have to multiply these two things. So friends, you will get this. P is nothing but 1 by 2 Vm. When you will multiply these two terms and when you will solve this, you will get P is equal to 1 by 2 Vm Im cos theta v minus theta I, means the phase angle between two quantities. Okay, theta v, suppose this is your voltage making angle theta v. This is your current, suppose making angle theta I from the horizontal. So in between them, the angle will be phi v minus phi I. So your power, total power, when you will multiply it, Vm, Im, cos phi, where phi is the angle between current and voltage. Please remember this. Now, a resistance load R absorbs power at all times. Resistance R, we have seen the graph for the power for resistance only. So for the resistor, I can say a resistance load R absorbs power at all times, while a reactive load L or C absorbs zero average power. Why zero average power? Friends, earlier I told you power. The simple definition of the power is, mathematical expression is It cos phi. Phi is the angle between current and voltage. Is it okay? Now, here in this case, the power will be, if you will take the maximum value, it will be Im cos theta v minus theta I. So you can remember this one also. This is the general, if you are taking Vm and Im over here. So in the case of, suppose in the case of capacitor I'm talking, capacitor power I'm going to measure. You'll be having something Vm, yes, okay, no problem at all. You'll be having some Im, okay. But what is the angle between current and voltage in capacitor? We have seen in the last class, the current and voltages, they make angle 90 degree for capacitor and inductor. Okay, so the angle or phase difference between current and voltage for capacitor and inductor is completely 90 degree. So cos 90 is 0. So power across capacitor is 0. Power across inductor for a given time is 0. Okay, that's why I'm saying LNC absorbs zero average power. Zero average power. Come here, in this question, he is saying that Vt is given, It is given. Find the instantaneous power and the average power absorbed by the passive linear network. See, to absorb power, instantaneous power and the average power. And you know, the instantaneous power is just multiply Vt and It at any moment. This is instantaneous power. What about average power? Average power is given by Vm Im divided by 2 cos angle between voltage and current. Right? So this is about average power. Come to the instantaneous power first. You have given with Vt and It over here. You have to multiply simply into 10 cos 377t plus 45 degree and cos 377 minus 10 degree. Okay, this is 10. So this becomes 1200. This is like cos A, cos B. You can apply 2 cos A cos B formula. This will be 600 cos A plus B. The formula is cos A plus B plus cos A minus B. I think you remember this formula. So when you will solve this, you will get, wait a minute, I'm giving data. The power will be 344.2 plus 600 cos 754t plus 35 degree. This will be nothing but your instantaneous power. But if we'll talk about the average power, it's very easy to calculate. Vm. What is Vm? The maximum value of the voltage, 120 into current, 10 divided by 2 cos angle between these two terms, 45 and minus 10, obviously it's 55 degree. Correct? See, this is the 45 degree in plus 45 degree. This is minus 10. Minus 10 somehow here. Minus 10. So the total between angle is 55. So simply 55. So when you will calculate this value, you will get 344.2. This is nothing but average value of the power. In this equation C, if you will take the average of this, it will be 0. This will be remain. This is the average power. I hope this is clear to you. The first question. In the second question, calculate the instantaneous power and the average power absorbed by the passive network. This question is similar to the first one. So please try it. The answers is given over here. Now come to the third one. In the third one, this is the third one. Calculate the average power absorbed by an impedance. Z is given when voltage is V equal to something is given. He is asking for the average power. Again, the average power is Vm Im cos angle between current and voltage. This is the equation and divide by 2 also. So, you are having impedance. We are having some impedance 30 minus J70. Okay, fine, perfectly fine. Applied voltage is 120 at an angle 0. Okay, fine. So if you will be having I in this, you can calculate power easily. So I will be 120 at an angle 0 divided by 30 minus 70J. Is it clear to you? When you calculate this value, this value will be 1.576 at an angle 66.8. This is the current value when you will going to solve this. Okay, this is the current value. I'll write the voltage value also 120 at an angle 0. Now your task is to calculate the average power. Average power, what is Vm? Vm is 120. What is current? 1.576 divided by 2 cos the angle between voltage and current. The voltage angle is 0. 0 minus 66.8. Now you can easily solve this. When you will solve this, you will get P equal to 37.24 watt. This is about the power. Okay, is it clear to you how to calculate the average power? The formula for the average power is always Vm Im cos angle between voltage and current in the element divided by 2. I hope this is clear to you. Come to the next topic, and that is the effective or RMS value. Friends, what is the RMS value? See, we are talking about the AC circuits, right? Suppose take Vt. In general, the expression for Vt is given Vm cos omega t plus phi. This is the general equation. We have seen it. Vm is the max value, omega is the angular frequency, phi is the angular difference. So, after all, this is the AC waveform. Suppose you are taking Vt equal to Vm sin omega t. Let's take it. If you will take it, the waveform is like this. This is time period t take. Correct. Now friends, if you will take the average value directly, what will be the average for this? Will it be 0 or not? Vt average will be 0. Why? Because the positive half and negative half, they are just equal to each other. So for this particular time t, the average value is 0. Yes. So average value for the sinusoidal function is not the effective quantity or effective term. So we need to come with idea of effective value of any current or voltage given AC circuit. Given AC voltage or AC current, you should be having the effective value. Effective value means that value can represent that particular signal. Average can't represent, because in particular time interval t, the average value for any AC signal is 0. Because in particular time we are getting two halves, both are equal and opposite to each other, they will cancel to each other, you will get 0 in your hand. So come to the effective values and R, that is the RMS value. What RMS says? The idea of the effective value arises from the need to measure the effectiveness of voltage or current source in delivering power to a resistive load. The effective value of the periodic current is the DC current that delivers the same average power to a resistor as the periodic current. See, mathematically, I will talk about the RMS value, root mean square value. Root mean square value. So, inside you will be having a square. We will take mean of that square and then you will root it. Root mean square value. You will start with the square. So, suppose you are going to calculate RMS value of some quantity x. Okay, first take the square. Here is the square, x square. Then mean. What is the mean? From 0 to 2 t, suppose. In this interval, how to calculate mean? Average value. The total is like this. Divide by that interval. This is the mean. So square is over, mean is over. Now root. Just root it. This is the RMS value. When you will calculate for Vm we already considered, Vt we already considered Vm cos omega t plus phi in the last slides, right? So for this, the RMS value will be Vm by root 2 always. Vm by root 2. If we'll calculate this, we'll solve equations and derive this. So we'll get Vrms equal to Vm by max by root 2. Or suppose take any value, XRMS, take XRMS is nothing but X max divided by root 2. Is it okay to you? So this is the RMS value. It's very important. We'll see some problems based on this. The average power absorbed by the resistor in terms of RMS value. In terms of RMS value, I'm talking about the given formula is IRMS, I square RMS into R, V square RMS into R. The average power absorbed by resistor. For the resistor, the average power absorbed is given by P is equal to IRMS square into R, Vrms square into R. If you are having the effective current or voltage in your hand, you can take out the power in any resistance. Is it okay? Now come to the average power. Average power we can return in terms of like this. Why I can return this? See, the average power we have seen the formula earlier. And it was Vm into Im into cos the angle between voltage and current divided by 2. So this divide by 2, can I write root 2 into root 2? Yes. Vm by root 2, what I'll write? Vrms. Im by root 2, what I'll write? IRMS. RMS. Cos, this is theta v minus theta I. Here is the equation given like this. So, in terms of, suppose RMS values are given in the question, you can easily find out the average value. P is nothing but simple, you have to do Vrms, IRMS, angle between voltage and current. Here don't divide by 2, okay? Divisibility of 2 is for the max only. V max, I max divided by 2. Cos theta V minus theta, both are same, okay? Come to the next one. See, the question is saying, determine the RMS value of the current waveform. See, this is the current waveform given over here. If the current is passed through the 2 ohm resistor, find the average power. Average power also is asking for. So first, if you can able to find the RMS value for this circuit, the average power you can easily find out. IRMS square into R, right? First, we'll find the RMS value. See, is this periodic signal? Yes, this is periodic signal. Means 0 to 2 it's going like this. From 2 to 4 it's going like this. Again it's a repeating. So up to here it's a periodic. And the period of this signal is 4. Means every 4 seconds, suppose take this unit is second. After every 4 seconds the signal is repeating itself. So t equal to 4 is the time period of the signal. Okay. So we are going to calculate the RMS value. RMS value always calculated in single time period t, okay, or single cycle. So friends, come to the point. Point is RMS value we have to calculate. IRMS. IRMS is nothing but IT square. You have to take mean. This is mean and then root. This is IRMS. Okay. I'll take IT. First, I'll come with the values of IT. Here, the time is divided into 2 slaves, 0 to 2. In 0 to 2, the value of current given is, tell me fast, this is 5t. 5t. 10 divided by 2, this slope, and this is the 5t. This is the value of current in the region or in the slave 0 to 2. Now next, the same current is minus 10. Minus 10. See, minus 10 from 2 to, for time 2 to 4. This is all about. Now, come to the point. IRMS. Our task is to calculate IRMS. Now, to calculate IRMS, you need root. Okay, fine. No problem at all. Now, you are having total, the total time is 0 to 4. 0 to 4 is the total time. 0 to 4 IT square dt. Is it okay? This is all about 1 by 4. 1 by 4 is fine. Here inside you can divide because you are having 2 different currents for 2 reasons. First, 0 to 2. The current is 5t. 5t square dt plus 2 to 4. 2 to 4 minus 10. Minus 10 square dt. Is it okay? So, this is 1 by 4 under root. This will become 25 t square 0 to 2 plus 10 square 100 and this is t 4 to 2. Is it okay to you? So, 1 by 4 25 into 4 plus 100 into 2 if I am right. You can take 4 out over here. So, we'll be having 25 plus 8. Am I right? No, I'm not right. Making some mistakes over here. So, this is 50. This will be 50. 4 came out. 50 plus 25. So, your value is 75 under root. This is IRMS. For this question, IRMS is root under root 75. IRMS, yes. IRMS is root 75. Now, can you calculate average? Yes. IRMS square into R. IRMS square is nothing but square into R. IRMS square is 75 into R is 2. Sorry. This is 150 watt. This is power average. Very simple. Okay. Come to the next now. Apparent power and power factors. What is the apparent power? And we will see about different active and reactive powers also. Earlier we saw that if the voltage and current at terminals of a circuit are given Vt equal to Vm cos omega t plus phi v, and IT is given as Im cos omega t plus phi I. The average power is given by this formula. I think you remember now this. 1 by 2 Vm Im cos theta V minus theta I, the angle between voltage and current. Okay, fine. In terms of RMS also we have seen the formula. P is Vrms IRMS cos theta V minus theta I. This term I can replace with S, and this S is nothing but the apparent power. The apparent power in VA, volt ampere, the unit is volt ampere, is the product of the RMS value of the volt and current. Apparent power means suppose you are having some circuit. In that circuit you are giving some voltage VT, and due to that voltage the current is IT. So simply we know the power is V into I, right? We know power is V into I. But for the AC circuit the effective quantity is RMS. Vrms, IRMS. So at an instant you will see what is the apparent power. What is the apparent power denoted by S? Simply we will see RMS into IRMS. This is apparent power. If anybody will ask what is the apparent power, you will simply take effective values and will multiply it. Is it okay? This is the apparent power. This power is different from the instantaneous power. Instantaneous power is given for at a particular time, or any time you can give, because it's Vt equal to It into Vt. PT, power PT is nothing but Vt into It. It depends on time instances. But this is the fundamental constant quantity, Vrms into RMS. For any circuit, Vrms is fixed, you applied, RMS is fixed, whatever he is getting the current based on that. So Vrms, IRMS, this is the power, apparent power. Okay, so this is S, apparent power. I hope this is clear to you. Come to the next. The average power is a product of two terms. The average power is a product of two terms. The product is known as the apparent. The average power is a product of two terms. Okay, fine. Come to the apparent. The product Vrms, IRMS is known as the apparent power S, and the factor cos theta V minus theta I is called the power factor. Cos angle between current and voltage is given the definition power factor. What is the power factor? The cosine of angle between voltage and current in any element is nothing but the power factor. Come to this note. The apparent power is so called because it seems apparent that the power should be the voltage current product, as we know about this. By analogy with DC resistive circuit, it is measured in volt ampere or VA to distinguish it from the average or real power. For the average and real power, the unit is watt. But this is the apparent kind of thing. To distinguish this power from the average power, we are giving the unit is V into A. V for voltage and A for the current, ampere. So volt ampere. Okay. The power factor I dimensional is, since it is the ratio of the average power to the apparent power. Power factor. Okay, this is all about the power factor. Power factor is the unitless. Okay. Now, the power factor is the cosine of the phase difference between voltage and current. It is also the cosine of the angle of the load impedance. We'll see later about this. Come to the next one, and the next one is, come to the question now. Here in this question, let me take pen first. A series connected load draws a current IT is given over here and applied to the voltage VT. Find the apparent power. So they are asking for find the apparent power and the power factor of the load. Determine the element values and from the series connected load. So for this question, they are asking for the apparent power. Now the given values are IT is 4 cos 100 pi t plus 10. Correct? And the value of Vt is given 120 cos 100 pi t minus 20. We have seen earlier the apparent power is Vrms into IRMS. What is the Vrms? Here V is given 120. This is the max value given over here, Vm, and this is Im, the max value. And you know the formula. If you want to calculate Vrms, Vrms into Irms. Here okay, but here Vrms is nothing but Vmx by root 2. So here Vrms is nothing but 120 by root 2. Irms is nothing but 4 by root 2. So this is 120 into 4 divided by 2. So this is 240 volt ampere, right? This is the apparent power. Now next he is asking for the power factor of the load, and the power factor is nothing but the cosine angle of the angle between I and T. The angle of I is given 10 degree. Let's take positive 10 degree over here. The voltage is given minus 20, minus 20. The overall angle in between them is 30 degree. So the power factor is cosine angle of 30 degree, means root 3 by 2, means 0.866. So this is power factor. Okay. I hope this is clear to you. Now the next question, determine the element value that from the series connected load. So what is the element value? Element value is nothing but ZV by I. The V is given over here, 120 at an angle minus 20, and current is given 4 at an angle 10. When you will solve it, you will get Z equal to 25.98 minus 15J. So this is your element. Here this is the value of resistor and 15 is the value of capacitance, C. Right? Means capacitive reactance. Xc is nothing but minus 15J. Okay. So this is all about the first question. Come to the second one. Obtain the power factor and the apparent power of the load whose impedance is given, and the impedance 63 plus 40 j ohm when the applied voltage. This is homework to you. The answers are given over here. You can cross check it. Come to the complex power now. What is the complex? Actually, when current and voltage values are given in the complex form, means Z equal to X plus IY. This is the complex number. In that case, the all power becomes complex power. Consider the AC load C. This is one of the question kind of thing. Consider the AC load in the figure. See, this is the AC load over here. Given the phasor voltage, this voltage value is given Vm theta V. The value of I is also given Im at an angle theta I. This is Vm at an angle theta V. Correct? Now, the voltage Vt and current It, the complex power As absorbed by the AC load is the product of the voltage and the complex conjugate of the current. If they will ask the complex, this is apparent power. Nothing but this is the apparent power we have seen earlier. We have seen Vrms into Irms. But if the Irms is in the form of, the complex number, then in that case, we will take S equal to Vrms into Irms conjugate. Okay. And what about these three forms? These three forms, S is nothing but I square Rms into Z. We will take over Z here. Or V square Rms divided by Z conjugate. Or Vrms, you have seen this formula. Okay. So this is the apparent power in the complex is Qj. P is the active power or real power or the absorbed power, and Q is the reactive power. And S is the apparent power in the complex circuitry I'm talking about. So P is nothing but the I square Rms into R. P, this is the real power absorbed or average power. Average power we have seen earlier, the power absorbed by the resistor, and that is I square Rms into R. Now what is this Q? Q is the power absorbed by the capacitor and inductor at instant. Though for the given whole period, they are not taking any power from the circuit. Okay. So that's why this power is the imaginary power. Means whatever they are taking in the first half, in the negative half, they are dissipating that power. So in the entire time period or entire cycle, the power is zero. So there is a no consumption. But still there is an appearance of power across to this time capacitor and inductors, and that is nothing but I square RMS into X. Here X is the reactance. Okay. Now P is nothing but Vrms Irms cos theta V minus theta I. Similarly, this is the active power. Please, this is active power and average power. I can say average power is the power consumed by the resistor. What about Q? Q is nothing but Vrms Irms sine angle between theta V and theta I. Sine angle between current and voltage. Okay. So I hope this is clear to you. You are having the power S, apparent power, the power P, active power, the reactive power Q, and this is the imaginary power, where P is given by this formula. P is nothing but Vrms RMS into cos theta V minus theta I. Q is the reactive power given by Vrms Irms sin theta V minus theta I. S is the apparent power, complex power. So S is given by Vrms into I conjugate of RMS. This is the formula you can use for it. Or if you are having only Vrms value, so you can use it. If you are having Irms only, square into Z you can use it. I hope this is clear to you. Now come to the P. P is the average or real power, and it depends on the load's resistance R. Q depends on the load's reactance X and is called the reactive power. Okay. Is it clear to you? So come to the final sum up of the power. The complex power is P plus Qj. Okay. If you will take it on the axis, suppose this is x-axis, this is y-axis, this is imaginary. This will show imaginary part and x will show the real part. If on the real part we have P, right? On the imaginary part we are having Q. This is Qj, correct? Resultant of this is nothing but the S. So this is S, this is Q, and this is P. So here I can write S square is nothing but P square plus Q square by Pythagoras. Okay. So complex power S is given by RMS, IRMS, Vrms, angle between them. Apparent power, I called it apparent power. Apparent power formula is, if mode I am talking about, it's P square plus Q square root given over here. If we'll talk about the real power is, this is the real power S. S is nothing but Vrms, Irms into cosine of angle between current and voltage. Reactive power, I'll take sine. Okay, I'll take apparent power S will multiply with sine theta V minus theta I. What is the power factor? Power factor is P by S. That is the cos theta V minus theta I. Is it clear to you? Come to the mutual inductance now. Friends, if we'll talk about the inductors, it has L. This is the inductance given in Henry, right? If the current will flow in it, it will be having some magnetic field around this. Just near to this L1, if you have another inductor L2, in that also you are flowing the current over here. So this type of situation, you will generate one mutual inductance in between L1 and L2. I'll give it the name M, mutual inductance. In such case, you'll be having mutual inductance also. We'll see over here. When two inductors or coils are in a close proximity to each other, the magnetic flux caused by current in one coil links with. So again, when two inductors or coils are in a close proximity to each other, the magnetic flux caused by current in one coil links with the other coil, thereby inducing voltage in the latter. This phenomenon is known as the mutual inductance. What this statement is saying, that when current will flow in this, due to magnetic field, the same thing will linked with this also. So here also we'll get some voltage due to this. So this relation between these two coils is given by the mutual inductance. They are sharing one mutual inductance also, that is the mutual inductance. So mutual inductance is the ability of one inductor to induce a voltage across a neighboring inductor measured in Henry. The unit is same for the inductance and mutual inductance. For the L, the unit is Henry. For the mutual inductance M, unit is Henry. Okay. So this is the inductance. between two coils. L is the inductance of separate single coil. M is the mutual inductance, or I can say the inductance sharing by the two coils. Okay. So this is about the mutual inductance. From the next class onwards, we'll see some more details about mutual inductance and we'll solve some problems. We'll meet in the next video. Till then, take care and bye.